Bismillahirrahmanirrahim. Okay, ji. So last time what we did was Bismillahirrahmanirrahim. Last time we did a number of examples. We started with the sinusoidal input. We discussed half wave rectification. We discussed the disadvantages of half wave rectification. Then we discussed the half wave rectification with ideal and then practical diodes. And while discussing the practical diode version, we observed that there are two major differences, which is the offset voltage and the voltage drop. If the voltage input is very large as compared to the potential drop, barrier voltage drop of the diode, then these changes can be ignored. So there was an offset addition while using practical diodes, and there was a drop of 0.7 volt if we had used silicon and if we had used 0.3 volts of the germanium diode. After the half wave rectification, we came to more practical circuits. And yes, for the half wave rectification, we also discussed the peak inverse voltage, that is the PRV voltage. And we found that the rating of the diode when used in half wave rectification should be equal to or larger than the maximum peak voltage applied at the input side. Then we came to full wave rectification. We discussed or we learned two circuits. First circuit consisted of 4 diodes, as we can see in the slide. This circuit is called the bridge network because it consists of 4 diodes. The convenience of using such circuit is that we need a normal transformer. We do not need a specialized transformer, as we will see in a later case. However, the disadvantage of using bridge network is that we are using 4 diodes. Each diode will have a voltage drop depending on its silicon, or depending on whether either it is silicon or germanium. And since there are 4, therefore 2 diodes will work in each half cycle. There are 4 diodes, 2 diodes will work in each half cycle. So when 2 diodes are working, then the voltage drop will be 0.7 volt plus 0.7 volt, that is equal to 1.4 volts. Then we learned the procedure, what happens in the positive half and what will happen in the negative half, or which diode will conduct during the positive half and which diode will conduct during the negative half. And then we learned that the DC output voltage is equal to 0.636 times V maximum, or the V peak voltage. Then the peak inverse voltage for full bridge network should be equal to or greater than the peak voltage applied at the input side. Right, then we learned the center tap transformer. This is a circuit, rectifier circuit, which works with diode along with a center tap transformer. A center tap transformer is a transformer which has 3 terminals connected available at the secondary side, such that 2 windings should be of equal number, that the winding should have equal number of turns. The voltage appearing across each winding should be equal. It should be 50% each. Only then we will get a balanced DC output. Then we are using 2 diodes D1 and D2 as shown in figure 2.60, and each diode will conduct during one half cycle. So for the circuit shown in figure 2.60, D1 will conduct during the positive half, D2 will conduct during the negative half. The output voltage again has a DC voltage of 0.636 times Vm, and the peak inverse voltage for standard type transformer case should be equal to or larger than twice of maximum voltage being applied. Now we come to today's lecture. Today's lecture, we will only discuss ripple voltage. Ripple voltage is the difference between peak to peak voltage of the AC signal divided by the DC output. Let us discuss this diagram. This diagram shows is AC power supply and then one diode and a resistance. The AC power supply is connected with is supplying our sine wave. The diode will rectify and the resistance R will only get the positive half cycle. So we can see that in this circuit, the voltage starts from 0, reaches its maximum point and then falls back to 0 again. The nature of the voltage is DC. It is a direct current. It is not alternating voltage. It is not AC voltage or AC current. It is DC. But the DC that we are familiar with is that on the x-axis if we have time, on the y-axis if we have voltage DC, then the DC voltage that we are familiar of is that it should be a constant value. It should be one directional, but it should not change also. However, if we compare the ideal DC with our obtained DC from the rectifier, we observe that there is a large difference. This difference is due to the ripple voltage. And the ripple voltage in our case is that if we take the difference from the peak to the minimum voltage. So the minimum voltage is 0 volts. The maximum voltage is Vm in our case. The ripple voltage is then Vm. It is very large. This is the ripple voltage. It is the difference between the peak and minimum of the output voltage. The ripple voltage ideally should be 0. And this can be seen if we look at our ideal voltage. If we look at our ideal voltage, in this case, in the ideal DC voltage, the ripple is approximately 0 volts or approximately 0. But the voltage obtained from the rectifier is very large. The ripple voltage is very large, equal to the peak voltage. So we have to decrease the ripple voltage. Our ideal is 0 and we have to approach 0. We have to approach our ideal ripple voltage, which is 0. The ripple in single diode rectifier case is maximum. And we can decrease the ripple voltage by connecting a capacitor in parallel with RL. This we will see in a later slide. In this circuit, if we reverse the connection of diode, what will happen? If we use a diode in the opposite direction, if we use a diode in the opposite direction, what will happen? We will get the output voltage again having ripple, but the output voltage will be minus DC voltage. It will be a negative, it will have a negative polarity. And in this case also, we have a ripple voltage which is very large. In this case also, the ripple voltage is very large. So it does not matter if we use the diode to rectify the positive half cycle, or if we use the diode to rectify the negative half cycle. In both cases, we will get ripple voltages. And the only solution at this stage to reduce the ripple is connecting a capacitor in parallel with the load. This was the performance while using a single diode. Now let us come to the performance of our
Sir, kindly believe the what is ripple voltage?
हाँ जी. So ripple voltage is the maximum to minimum voltage available at the output. Ripple voltage is the maximum voltage output minus minimum output voltage. Ripple voltage is the difference between maximum output voltage and minimum output voltage. In our ideal DC sources, we get a constant line. The minimum and maximum are the same. The minimum output voltage and the maximum output voltage are the same. Therefore, in ideal cases, the ripple voltage is zero. However, when we are using a diode to rectify AC to DC, at that time, the maximum output voltage is equal to the peak voltage. This is our maximum voltage. This is our maximum voltage. This is our maximum voltage. And the minimum voltage is over here. This is our minimum voltage. The difference V ripple is equal to V maximum minus V minimum. This is the ripple voltage. And we should design a power supply. We should design a power supply which has ripple voltage approaching or trending towards zero. So we do not like ripple voltage. We would like ripple voltage to be zero. And we will find two solutions to reduce this ripple voltage. Now, how do we remove this? How do we remove this ripple voltage?
सर मैक्सिमम हमारे सपोज के 10 वोल्टेज है, मिनिमम हमारे 0 है, तो उनका डिफरेंस 10 आएगा. अगर दूसरी मिसाल दें, मैक्सिमम 10 है, मिनिमम हमारे 2 हैं, तो वो 8 आएगा. तो इट मींस हमारे रिपल वोल्टेज 8 होंगे.
रिपल वोल्टेज 8 होंगे, बट मिनिमम आपका 2 क्यों होगा आपका? हमें तो मिनिमम 0 चाहिए. हमें तो मिनिमम using this circuit, how can we get 2 volts from this circuit? While using a single diode, how can we get 2 volts? लेकिन कॉन्सेप्ट आपका ठीक है. लेकिन आपका जो कॉन्सेप्ट है वो ठीक है कि अगर मैक्सिमम वोल्टेज 10 वोल्ट्स हैं और मिनिमम वोल्टेज 2 वोल्ट्स है, then the ripple voltage is 8 volts. In this case, if maximum voltage is 10 volts and minimum voltage is 2 volts, and then the ripple voltage in this case will be only 8 volts. But I want to clarify that in this circuit where we have one AC power supply, we have one diode and we have one resistance, we cannot get 2 volts. We will get maximum voltage, V peak, or we will get 0. We will get V peak when the diode is conducting, or maximum that you can consider is if you want to consider the 0.7 voltage drop, then the maximum voltage will be Vm minus 0.7, this will be our peak voltage. And then for the unrectified case where the diode becomes reverse biased, during this time, during this half cycle, the output voltage will be 0 volts because there is zero. When this zero current multiplied by RL gives us 0 volts. When the diode is reverse biased, the diode becomes an open circuit. During an open circuit, the current is 0. When there is 0 current, the voltage across RL, which is our output voltage, the 0 current will produce 0 volts. So in the reverse bias, we can only get 0 volts because circuit becomes open circuit.
ठीक है, लेकिन सर इसकी जो वेव्स बनती है वो आइडियल में वो डायरेक्ट स्ट्रेट लाइन है, अगर वो रिपल्स होते तो वो किस तरह बन जाती वेव्स?
हाँ, वो आगे हम देखेंगे, वो नेक्स्ट स्लाइड में आएगा।
ठीक सर,
वो नेक्स्ट, अभी तो हम सिर्फ डिफाइन कर रहे हैं कि रिपल वोल्टेज क्या होता है
ठीक है,
और रिपल वोल्टेज की आइडियल वैल्यू क्या होती है और रिपल वोल्टेज इन प्रैक्टिकल सिंगल डायोड केस क्या होगा। तो जो रिपल वोल्टेज है, रिपल वोल्टेज इज द डिफरेंस बिटवीन मैक्सिमम वोल्टेज एंड मिनिमम वोल्टेज। सेकेंड ये है कि द आइडियल रिपल वोल्टेज इज जीरो। आइडियल रिपल वोल्टेज जीरो कहाँ से आ गया कि आपके पास जो आइडियल पावर है, फॉर एग्जांपल आपके पास एक डीसी सेल है या डीसी बैटरी है आपकी, जो फॉर एग्जांपल जो ऑटोमोबाइल्स होती हैं उनमें जो लेड एसिड बैटरी यूज की जाती है, that battery produces a straight line. It does not produce sine wave or rectified sine wave. It produces a straight line. या फिर जो आपके इलेक्ट्रोलिसिस के हेल्प से, हम जब इलेक्ट्रोलिसिस के हेल्प से जब हम डीसी वोल्टेज हासिल करते हैं, then the DC produced from electrolysis, which is the source of DC, is also a straight line. So that we say it is straight line because the ripple voltage is zero. Ripple voltage ideal case में V maximum और minimum दोनों बराबर हैं, therefore ripple voltage is zero. से फिर हम ये कॉन्सेप्ट लेते हैं कि एक जो आइडियल डीसी पावर सप्लाई है उसमें जो रिपल वोल्टेज होगा वो हमेशा 0 वोल्ट्स होगा। तो हमने जो पावर सप्लाईज डिजाइन करनी है, they should have properties very similar to your ideal power supplies. ठीक है?
ओके सर।
जी, so this is the AC input. It is providing us AC sine wave like this, and then with the help of single diode, what we have achieved is a DC voltage. This DC voltage available at RL, across RL, it is DC because the output voltage does not enter the negative region. Since the voltage is working in the positive region, whatever is the value, since the values are all positive, they are not negative. Since all the values are positive, we say that it looks like a variable, it looks like half sine, but it is DC in nature. By conceptual wise, in concept, in theory, it is a DC because the polarity is not changing. The polarity of RL will not change. Therefore, the output voltage is DC. However, it might look like AC or might look similar to AC, but it is not AC. It is DC because polarity is not changing. ठीक है? It can be a worst case of DC. It can be a bad example of a DC, but it is DC. We can never categorize it as AC. Now, the remaining work to do is how do we rectify or how do we correct this large ripple? We want a ripple of very small value. Our best value is 0. How do we rectify or how do we correct such a behavior. So in the next slide, we will discuss the addition of a capacitor, and the sole purpose of using the capacitor is to remove the ripple voltage and get a voltage which looks very similar to your ideal output DC sources. So this is the same circuit, but in this circuit we have added or inserted, or we are taking the advantage of a capacitor which is connected in parallel with the load RL. The circuit is the same except for the addition of an capacitor. तो अब यहाँ पे AC input और then we see this component. ये component कौन सा है?
सर ट्रांसफार्मर.
This is our very normal simple transformer. What is this transformer doing at this location?
Step down, sir.
ठीक है. As a hint, I will give you a hint that this transformer is performing two functions. What are the two functions being performed by this transformer? Yes, any answer? What are the two functions being performed by the transformer?
सर वोल्टेज को स्टेप डाउन कर रहा है और मेरे ख्याल से करंट को इंक्रीज कर रहा है.
देखिए, वोल्टेज को स्टेप डाउन करे या करंट को इंक्रीज करे वो बात तो एक ही है. Because we have a very well known transformer equation, that is voltage of the primary divided by voltage of the secondary is equal to current of the secondary divided by current of the primary. So it can be the first function, but it is not both functions. बिकॉज फॉर्मूला एक ही है. आप वोल्टेज में बात कर लें या करंट में बात कर लें तो बात तो एक ही है. आप कह सकते हैं कि जी वोल्टेज स्टेप अप कर रहा है या वोल्टेज स्टेप डाउन कर रहा है, तो इसका मतलब है अगर वोल्टेज स्टेप अप कर रहा है तो करंट को स्टेप डाउन करेगा, अगर करंट को स्टेप अप करेगा तो वोल्टेज को स्टेप डाउन करेगा. बिकॉज ये जो फॉर्मूला है ये तो वैलिड रन है. और आगे इस फॉर्मूले में अगर हम कंप्लीट करना चाहें इस फॉर्मूला को, तो वी हैव द नंबर ऑफ टर्न ऑन द प्राइमरी divided by number of turns on the secondary. This is the complete formula. So this can be the first function of the transformer, but what is the second function of the transformer? ये जो फॉर्मूला मैंने लिखा है ये सबको समझ आता है ये?
Yes sir.
So this is your normal transformer equation. Okay जी, तो the first function is to step up voltage or step down voltage. If the primary number of turns is smaller than the secondary, then we will get step up transformer. If the primary number of windings is larger as compared to the secondary number of windings, then we get a step down transformer. So ठीक है जी, एक तो काम फंक्शन नजर आ गया कि जी आपने वोल्टेज को स्टेप अप करना है या स्टेप डाउन करना है डिपेंडिंग ऑन द winding number of turns. What is the second function? Okay ji, so everybody please listen that the two functions are, first function is either voltage step up or step down. तो ये जो windings हैं ये क्या शो कर रहे हैं? There are two different windings. And then what is this straight line?
स्ट्रेट लाइन कोर को शो कर रही है सर.
So the straight line shows the core. Are the primary and secondary windings, are they in any form, are they connected to each other?
Sir.
The primary and secondary windings, are both of them connected to each other in any form?
इलेक्ट्रोमैग्नेटिक वेव्स की वजह से हैं सर, इलेक्ट्रोमैग्नेटिक इंडक्शन बेस पे.
No, लेकिन that's not connection. Are they connected? कोई आपने कोई उनको वायर्स कनेक्ट किया हुआ है या आपस में एक वाइंडिंग से आप निकाल रहे हैं?
नहीं सर, वो रैकी कपल नहीं है सर.
So yes, so the transformer works on the principle of magnetic induction, and thus the second function is that the primary and secondary windings are isolated from each other. They have galvanic isolation between each other. There is no electrical connection between the primary and secondary winding. Therefore, the primary circuit and the secondary circuit are isolated from each other. They do not have any interconnection. Thus, the two functions of the transformer, first function is to step up or step down voltage. Second function is to provide isolation. Second function is to provide isolation. So this transformer producing AC output voltage is then provided to the diode. The diode sees a capacitor and a resistance RL. The advantage of using the capacitor is that now we see this thick black line. This thick black line is the output of the DC rectifier using a capacitor. Output waveform with capacitor. Whereas the dashed or the dashed line, or if I can make it more clear, this red colored line shows the output of the capacitor, the output waveform without capacitor. Now remember that we need a straight line for our ideal case. The output waveform with capacitor looks much similar to the ideal case. Hence, the capacitor has helped us in reducing the ripple voltage. If we disconnect the capacitor, then we will again get the half sine wave DC voltage, which has increased the ripple voltage. When we connect the capacitor, then we will find that the ripple voltage has now decreased. तो अब आप इसमें ये देख लें कि कैपेसिटर को ऐड करके हमने किया क्या है. What have we mathematically, what have we done by adding the capacitor?
So we have an extra power source.
इसको अगर एनालिटिकली आप देख लें कि एनालिटिकली what have we done by the addition of capacitor?
सर डिले पैदा करवाया.
No. There is no delay. What we have done is that if we look analytically देखना है इसको कि कैपेसिटर तो आपका एक फिजिकल कंपोनेंट है, बट मैथमेटिकली आपने क्या किया है? What we have done is that we have the ripple voltage. Let us write the ripple voltage again. Ripple voltage is equal to V maximum minus V minimum. So by adding the capacitor, what we have done is we have increased the minimum voltage. This is our minimum voltage. ये यहाँ पे है minimum आपका. ये नजर आ रहा है सबको?
Yes, sir.
So mathematically we have increased the minimum voltage. We have increased the minimum voltage. When we increase the minimum voltage, then the voltage ripple, according to this formula, the ripple voltage will now be decreased. Because without capacitor, the minimum voltage was 0. With capacitor, the minimum voltage acquires a certain value. Thus, the ripple voltage is now decreased. तो अब जरा यहाँ पे आप जरा देख लें कि जब आपने कैपेसिटर नहीं लगाया था तो वी मिनिमम था आपका 0, वी मिनिमम था 0. When we add capacitor C, we get a finite value of V minimum. So does this mean that our best value is to use infinite capacitance to solve this problem and get ideal straight line? जवाब दीजिए इसका.
with capacitor, sir.
अगर हम जरा ट्रेंड को देखें ना कि विदाउट कैपेसिटर वी मिनिमम इज 0 वोल्ट, विद कैपेसिटर सी we get some value of V minimum. Ripple voltage is decreased. Now if we double the value of C, what will we get?
हम स्ट्रेट लाइन हासिल कर लेंगे सर.
जी
स्ट्रेट लाइन हासिल कर लेंगे सर.
Sir,
So
V
if
minimum is by 0.63 times, right?
what value?
Sir, with each capacitor, V minimum increases by 0.63, मतलब 63%, right?
No. This is not the concept. By increasing the capacitance, definitely we will get a larger V minimum. By increasing the capacitance, we will increase V minimum. But there is a certain disadvantage that we should not use large capacitors, because if we use a very large capacitor, then no doubt our ripple voltage will be decreased. We will get a very smooth DC output. But what will happen when we turn off the transformer? When we want the circuit to be turned off, our capacitor will remain charged and it will keep on continue to provide charge to RL. It will continue to provide current to RL although you have switched off the circuit. The circuit will remain active because we are using a capacitor of very large value.
Excuse me,
So
sir?
although the capacitor helps, large or very large capacitors, they help in decreasing the voltage ripple, but at the same time we are left with an uncontrollable circuit. Uncontrollable in sense that if we switch off the device will remain active until the capacitor loses all its charge. ये बात समझ आई है सबको?
Yes, sir.
Yes, sir. Sir, I have a question.
जी
I have a question, sir.
जी बोलें.
Sir, it won't matter that capacitor is charged or not. When we have switched off the circuit, there is no need for circuit for us. So if the capacitor, even if the capacitor is charged, the current would flow through RL and the capacitor would be discharged within some seconds or milliseconds. So it doesn't really matter if
But
the capacitor is charged or not.
Yes, I understand what you're saying, but it's not seconds. If we are using a very heavy capacitor, since the capacitor is directly connected across the load. Therefore, if we disconnect the transformer, and this means that we want to turn off our device, but the capacitor will not allow the RL to be turned off until it is discharged. And if the capacitor value happens to be very large, then it can take longer times. The 5 time constants can take very long times. Just because that we wanted to get a straight line, we have to pay a price that our RL remains on. And this we often observe in our electronic circuits, that often we see that there are circuits which have LED indications that if the circuit is on or off. When we switch off the circuit, we see that the LED still remains on. ये देखा किसी ने?
Yes, sir.
Yes, sir.
Yes, so I think everybody has observed that even if we disconnect, we still observe that there is light coming from the indicator the circuit is on. This is due to the fact that the capacitor in use inside has charge. It is still providing charge to the circuit, and the circuit is active. And that is all related to this capacitor being used for reducing the ripple voltage. And also there is another factor that large capacitors, they will require more space. They will they will require more volume. ठीक है?
Sir, what?
तो okay, जी पूछें.
Sir, what type of waveform we observe when we increase the capacitance of a capacitor?
The waveform, first of all, the waveform for a medium capacitor will look like this. Then when we increase the capacitance, this waveform, it will now have a smaller ripple. It will look like this. With a larger capacitor, the ripple will be reduced.
Actually, I have a question. What if we put two diodes in series? Being and other
No, that is something else, because I have not shown the circuit of a full bridge. You are talking about full bridge circuit.
No, sir, not full bridge. I know that. Just like a single diode, if you put two diodes in only one line and reverse the polarity of one diode, will the current flow?
That is, you want a diode in this direction?
Yes.
Well, if we use, okay, let me draw again. If we use a diode, additional diode like this, you mean like this?
Yes, sir.
But then let us say that this the original diode is called D1, so that everybody understands. And we have now added another diode called D2. Clear?
Okay, sir.
So when we have the positive half, of the input, D2 becomes reverse biased, D1 is forward biased. But since both are in series, D2 will make the circuit open circuit. ठीक है?
Yes, sir.
तो positive half में काम नहीं होगा. Then during the negative half cycle, although D2 becomes forward biased, but now D1 is reverse biased. Now D1 becomes open circuit. So
Okay.
unfortunately, we will not get any operation.
Okay,
ठीक है जी?
समझ आ गई.
So we will just use single diode in this case. Now this was the concept. This was the concept of using capacitors in parallel with RL. ठीक है? So I would like all the students to read from the textbook the ripple voltage, and in next lecture inshallah we the ripple voltage reduction for full bridge circuits and standard transformers. ठीक है जी? So we will now finish over here.
And sir,
जी पूछें.
and sir, what will happen?
Excuse me, sir, will you share these slides with us, please?
I would like to share the slides, but I'm still in the process of making these slides. So, okay, I think I've
You can
shared
share.
them already.
You can share the slides up till now.
I think I have shared it during in the last lecture. Okay, I'll provide a new lecture. I will provide the I will provide today's lecture also.
And one more thing, you are recording lectures, but some lectures are not available to the students. Can you please make it available for us?
Okay, I will. Actually, they are very heavy files, and it took me a
Okay,
very
you can
long
also
time to
upload it to
download.
YouTube. You can also upload it to YouTube.
चले ठीक है, मैं देखता हूँ इसको, मैं देखता हूँ. ठीक है जी,
Thank you.
ठीक है. तो
And sir, what will happen if we place?
हाँ जी बोले. What will
तो क्या
happen?
होगा
What?
अगर हम what will happen if we insert a inductor within the capacitor in parallel?
Yes, yes, we will discuss this also. So this we will do this step by step. We will discuss the insertion of inductance, and then the combination of inductance and capacitance at its particular slide in its particular lecture. But at this stage, we are just dealing with a single capacitor across a single load with a single diode. So let the time come, we will inshallah discuss this also. तो बुक रीडिंग सबने करनी है. बुक रीडिंग बहुत ज़रूरी है. एंड नेक्स्ट टाइम अभी से आप बेशक पढ़ लें व्हाट विल हैपन फॉर कैपेसिटर इन फुल ब्रिज रेक्टिफायर्स एंड स्टैंडर्ड टैप ट्रांसफार्मर्स. ठीक है जी. तो दोनों सीआर जो हैं वो मुझे भेज दें अपने अपने सेक्शंस की अटेंडेंस, ताकि फिर मैं रिकॉर्ड कर लूँ. थैंक यू वेरी मच.